Hello, welcome to Science Expeditions 2021. My name is Lori Vogel, and I am a science teacher. Currently, I'm a retired science teacher from Hamilton Middle School, but once a science teacher, always a science teacher. And I get a lot of joy in doing experiments and getting kids involved in science. I am very involved in working with West High School and Hamilton Middle School on their Science Olympiad team. And I have the great opportunity to volunteer at Goodman Community Center doing fun science things for the kids there in elementary school. So today I said, I'd like to show some more kids a cool science activity. Our topic today is lava action. Density does it. So we're going to take a look at lava lamps and your own experiment and see what we can find out about density. I hope you've gathered your materials and you can either work alongside me or you can just watch this video and then experiment with your parents when I'm all finished. This is a lava lamp and we can see that it has a special action of rising and falling and rising and falling. And we're going to talk about how this action happens and why this material rises up and falls back down again, because it's the same material. It hasn't changed. Oh, but it has changed a little bit. So we'll keep this lava lamp right here and we'll take a look at what density is. Now, density is about how closely packed the materials or the particles that a substance is made out of. This is water, and water is made of molecules. And these molecules have a certain density all their own. But if I bring another object to this water and I put it in, we can see that it floats. And this ball floats because it has a lower density. That means the particles or molecules that make up that ball are a lot more spread apart than the particles that make up the water. We can try another ball. And we can see that it's sunk so that the particles that make up the rubber ball are much more tightly packed together. They're very close to each other, so they're more dense and they sink in water. Things that are less dense float. Things that are more dense sink. And we can see that in a representation I made to help you understand. So I'm just making a model. It's not showing the real thing, but it's showing kind of what the real thing is like. And we see that the water, the molecules or particles in the water are a certain distance apart. But the particles in the ball are much closer together. So the ball is more dense than the water. But this ball that's floating is the least dense of all. It has particles that are further apart. So it floats on the water, which has particles that are more dense than this ball. This is a simple way of putting little dots to represent particles in a substance. We can look at one more substance that's even less dense. And that would be a gas. So you've done that before, blown bubbles into water, and those bubbles always rise up because those bubbles are way less dense than the water. Their particles are really far apart, and that makes them less dense than water. So a gas is always going to be less dense than a liquid, or mostly. So let's try our experiment and see how density works. I'm going to take this clear glass. Any glass will work. I just like to pick a nice, tall, skinny one. And I'm going to add water. And as I said, you can, I don't want that much water, so I'm going to get rid of some. I don't really need very much water. There, that's good. Now I'm going to take and add food coloring so that I can get that water red and so we can see it better. And food coloring mixes very nicely. It's about the same density as water, and it mixes very nicely. Now we're going to add vegetable oil. And you can put it in fast, you can put it in slow, whatever you like. But I guess fast works better because I just spilled. Thank goodness I have a towel here. Maybe a little more for good measure. And as I put that in there, you may be observing something. You may be noticing a very interesting thing. The water stays at the bottom, and we know it's the water because it's red, and the oil is on the top. It's floating on the water. And even though I might stir it up a bit or go like that, it still stays on the top. And as we said, that means that the oil is less dense than the water. The oil is less dense than the water. It always floats on top of water. The particles of the oil are a little further apart than the particles of water. Now we're going to do a chemical reaction to see if we can create this lava flow. So take your piece of Alka-seltzer and break it into at least 4 pieces. It could be smaller than 4. That's okay, because you're going to have a chance to do a bunch of experiments with your Alka-seltzer. Now I'm going to take 1/4 of a piece and I'm going to put it in, and we're going to watch for a chemical reaction. What is being created between the Alka-seltzer and the water? I hope that you're saying a gas is being created. Just like when I blew into the water, gas came up. And we see that a gas is coming up. Bubbles always show a gas. And those bubbles must be less dense, because look at what they're doing. They're going to the top. Bubbles going to the top. But if we watch closely, we can see that there's also bubbles floating back down. What color are those bubbles? They're red, aren't they? So what must be in those bubbles? They must have some of this water in the bubbles. We're creating a gas, and that gas wants to go to the top, but it grabs some liquid, and the liquid floats up to the top. But why does it come back down again? I'm going to add another piece of Alka-seltzer so we can continue to watch the chemical reaction take place and our lava action. So there's our gas being created. It's grabbing some water, bringing it to the top. What happens to the bubble when it gets to the top? Right, the air or the gas must be escaping. And then when the gas isn't in with the red bubble, the water sinks back down. Gas and water are less dense, so they rise up. But the water bubbles alone, let's see if we can find some that are going to sink down. It's pretty much action going on in there. The water bubbles, the little red bubbles alone, just water, are more dense than the oil, so they sink back down. And a bubble that has gas in it, enough gas to make it less dense, it rises back up. We get that rising up with less dense, sinking back down with more dense. Rising up. It's kind of like taking the water that's more dense and giving it some gas that gives it a little life jacket. And then that life jacket brings it up to the top. But then we take off the life jacket by releasing the gas, and the liquid ball or liquid bubble goes back down. Rising for less dense, sinking for more dense. There's a lot of action in that lava tube right now going on. So we can represent that action in another drawing. And we take this drawing and we can see first that the water was more dense than the oil, but then we added the Alka-seltzer and got a whole lot of bubbles. But those bubbles grabbed and carried some water up with them because the water and the gas together were less dense. And then we know it was more dense because it fell back down. Water and gas went up, less dense, and water alone fell down, more dense. That lava action that we see because density does it. I'd like you, when you finish your experiments, to draw a representation like I did that shows how the particles, when they're more dense, are far apart, and when they're less dense, they're more dense, they're close together, and when they're less dense, they're far apart. And we can get that rising and falling. Let's look for a minute again at our lava lamp. Now, we created that lava action with a chemical reaction producing gas. But this is a material that we can see has that rising action and falling action without a gas. So what's happening? Well, there must be rising material that's less dense. And then as soon as it gets more dense, it falls back down. Rising is less dense, more dense, back down. What's making it less dense? What's making it rise up? Well, you can see there's a lamp in there. It's heating it up. So that yellow material gets heated up, and then the particles spread apart. And as they rise, because they're less dense, heated particles spread apart. They rose up. But when they get up here to the top, they cool back down. And the particles get closer together, and it's more dense. So it sinks back down. Heated up, particles spread apart. It's less dense, so it rises. Cool it down, it's more dense, so it sinks. Lava action, density does it. Now you can do more experiments with this by trying different fun containers, putting together different amounts of Alka-seltzer, and experimenting with the lava action and what color do you like best? What size of Alka-seltzer gives you the best lava action? Where can you see density change the best? This blue one's pretty good. We're really seeing big bubbles of rising and sinking. I wonder if it's the shape of the glass. Well, I don't know, but I'm going to let you go and do a lot more experiments with this lava action with Alka-seltzer, oil and water, and different size containers. I hope you have fun out there today experimenting. Make sure you do your writing and your drawing to show physical representation as well that you can save, and you'll be able to remember your science experiment of lava action, density does it. Have a great day.